Terrific. Hey, everybody. Thanks so much for joining us today. I welcome you all. How many people do we have here signed up on us, Emily? How many people have joined?
The total was around 220. We have 35, 38, 41. Slowly, people are coming in.
Gotcha. Okay, so let's do the thing that this says here. So we just wanted to thank you for coming today. The reason why these three pictures are up is because I think we can see each of you that's coming, I assume, is coming in no small part because you're going to try to do personal leadership in your own life. You're going to take on the responsibility for being an early adopter, for someone who says this is the right thing to do, and I'm going to spend some of my money and time and resources to make it happen in my own life. And I just want to put forward three people that have been extremely inspiring for me and for others, obviously. So Julia Butterfly up there on the tree, she spent 2 years in an old growth redwood tree. And from that leadership, that was in the late 1990s, like 96, 97, the federal government so much attention was brought to the crisis of cutting down old growth redwood forests in Humboldt County that we actually got a $500 million payout that purchased a 7,000 acre old growth forest, the last one that was of any size. And really is a great deal about her own personal sacrifice and her personal leadership. There's thousands and thousands and thousands of people who marched and protested, but what she did of putting herself in kind of harm's way, they shot at her, they tried to blow her off her tree with a helicopter, they harassed her night after night with loud music, etc. And she endured for 2 years, including really hardcore winters. And we have the Headwaters Forest up here now. Alexandria Ocasio-Cortez, I think you guys would agree that she's helped bring forward a new way of thinking. So with Markey next to her, they have proposed the Green New Deal, which is really the foundation of Biden's energy plan. It's become political around the phrasing Green New Deal, but the actions within it, those are the heart of what we're going to be doing for the next 4 years. And I just want to applaud her for being a leader on that. And then Greta Thunberg, who I think has rocked the whole world with her protests for not showing up, kids not showing up at school on Fridays, speaking over and over about adults who are not taking action, even though they've promised to do so, how that is robbing the next generations of their future, the future that we've gotten to grow up in and live in, of a relatively healthy environment compared to the direction we're going with massive climate change, because we are right now, today, that is our path. The reason we're meeting is to try to stem this, to head it off, to change direction before it's progressively too late. And it's already too late for people like my mother-in-law who died in the Santa Rosa fires in 2017. People have died, islands have disappeared, species have disappeared, but we need to do our part to make that not become even worse. So I thank you all for showing your personal leadership and showing up today. So with that, could you go to the next slide, Emily? I'm just going to introduce us, and then I'm going to hand it off to our next presenters. So here we have, this guide is just a couple weeks old, put it out. This is a pocket guide to all electric retrofits of single family homes. Some people have joked that it doesn't feel very pockety because it's like 90 pages long. Let me assure you that we could have written hundreds of pages and that so much of our work over the last year was in tightening the language and making it readable so there's at least not an unreadable book, right? It has relatively small paragraphs and very succinct, tight language to just try to get you through the intellectual challenge, the things you need to learn. And just give you lots of products. So it's more like a recipe book for a chef, just all the different ingredients of electrification that you can now be familiar with. So that is on our website, redwoodenergy.net/research. It's the first one there. And I encourage you to download it if you haven't yet, and reach out to us if you have any questions. And that is the last thing I'll say, is that we're here to answer questions. We all have slides, but please put questions in the chat, and we'll try to interrupt and answer them as they go along to the best degree we can. We're going to save a bunch of time at the end so we can have these questions, get your questions answered about your own homes. Be selfish, go right ahead, ask your questions. All right, with that, I'd like to introduce Emily Higbee, who's our Director of Research at Redwood Energy. Oh, sorry, pardon me, it's David Starts. I'm just looking at the name there. So David Takahashi, he's from Boulder, Colorado, and he and his spouse have electrified their home. Take it away, David.
I'll go ahead and stop sharing, and then
yeah,
you can go ahead.
exactly.
Cool.
Okay, hang on. Here we go. Okay, this is David from Boulder, Colorado. This is David and his wife. We suffer from OCD. What we have done is actually taken our, do you see the timeline?
We don't see the timeline, we just see the first slide, right?
Okay, hang on. I was afraid of that. Now do you see the timeline?
Not yet.
No. Zoom, start behaving. Hang on.
Well, first while you get that up, Ellen Dooley asked the question, we'd like to find an electric option to replace our gas fireplaces. Jonathan Moscatello is on, and he's going to be presenting on ductless Minisplits. And I think that's what is maybe the most practical solution for you, Ellen. You have a 300 square foot room, so you need a small heat pump. All right, now we got the timeline up. I'll pause there.
Okay, so great. So I did a presentation to a group here in Boulder using something called Pecha Kucha format. It's basically you get 20 slides and you get 5 minutes. And I had to take this timeline that you're looking at and compress it into 20 slides, which I'm about to show you. So Pecha Kucha is 20 slides, 5 minutes, 15 seconds per slide. And let's go ahead and show you that. It's on YouTube. We'll send the link later. So new share. That boy. Share with sound. Yeah. So you seeing that?
Yes, we do.
Okay, here we go.
The next speaker, very, very interesting talk coming up. This is David Takahashi from Green Faith. All right, you got to turn off your cell phone.
I do.
Oh, sorry, that's his notes. Never mind.
Thank you for that. Okay. How are we doing? Yes. Okay. World's on fire. Abyss ahead. To thrive, carbonize, decarbonize.
Share screen. Share sound, optimize. Okay. Share.
A friend shared joy in owning EV with no
You can hear the
tailpipe.
sound, David.
Oh, you can?
Imagine
Great.
joy in tailpipe-free homes.
I can't.
A modest 60-year-old, 1,000 square foot everybody home. Boulder has 44,000 existing dwellings. Retrofitting cheaper than reconstruction. Extracting expensive ancient sunlight. Why? Retiring gas guzzlers seek renewable replacements. Wander through energy labyrinth step by step. The cheapest kilowatt hour is one not used. Upgraded 100 amp main service to 200. No fossil fuel is clean. Can switch to clean electricity. Energy audit stages, priorities, and timelines. Baseline blower door test helps measure improvement. Anticipates swaps before breakdowns. Ceiling and insulation are low-hanging fruit. Infrared real-time inspection invaluable. 4 a.m. during polar vortex, thermostat reads 66. These air source heat pumps operate to -17. The smaller compressor heats water, spending much less now than on natural gas. Replaced ducted central forced air heating, never had air. Electrified provides both heating and cooling, a mini split in an underserved room. Guilt-free hot water, the challenging switch. Hot water heat pump uses carbon dioxide refrigerant, now powered from our rooftop array. Low tech, lowest cost cooling, a quiet, self-insulating attic fan with a timer. Crack window where we want breeze. A decarbonized, fossil fuel-free finish line. We tossed our gas cap and tailpipe, hers a respectable 66, onto decentralizing. Under mature trees, poorly oriented, low-pitched roof, MapDwell's predicted 1.42 kW was deflating. Found inspired solar partner. Reduced grid use while selling seasonal surplus. Seeking self-consumption, designed a nanogrid, responsive, reliable, and resilient. Safe lithium-ion batteries in crawl space. 32 kW is 3 to 4 days of off-grid power. First year used 80 of 8,000 charge cycles. Monitors sync consuming and producing. Smart Sense monitor learns unique startup profiles. eGauge records watched circuits. Today's backup generator is distributed storage. When grid fails or rolls blackouts, harvest sunshine or draw on stored charge. Our carbon footprint started at 100 pounds per person day. Above 18 pounds per person day is warming. Our final 12 per person day is cooling us down. Cost compares to a fully loaded Tesla X. Reached 87 by 19 in under 4 years. Hers at minus 50. If you haven't begun, now is a good time. Decarbonize, decentralize, democratize, even if you rent. Remove life's tailpipes. Do, there is no try. Coming generations cheering we cooled it. Thank you.
Okay. Who's next?
I'm up. Thanks, David. All right, so
And
I will be
keep the
talking.
questions coming, just folks in
Okay.
the chat. Keep the questions coming in the chat, please. We'll happily support you there.
Yeah. Okay, so I'm just going to give an introduction to the different products in our product guide. It's basically like a long appendix to our guide. And then Tom's going to talk about our watt diet, using some of these products. And then Sean's going to be talking about the cost of these various products. So with that, yeah, our product guides are pretty extensive. They have all the home essentials and outdoor and recreation items as well. Mostly here we'll be talking about the, most energy intensive and thermal loads in the building. So cooking, water heating, space heating, and cooling, and dryers as well. Moving into HVAC, we're starting with the larger systems, ducted systems, going up to about 5 tons and as small as 1.5 tons. They are, they're typically bigger systems, and a few products go to colder climates. You can see the ambient temperature range here. Some of them go down to -10. And one important consideration that I've learned throughout this process of writing this book is that air handlers for heat pumps are typically 240 volt, where if you have a typical furnace and air conditioning system, that air handler you have for your furnace is 120 volt. So in thinking about the ducted systems, some manufacturers have a workaround for this. They'll have a way to connect the compressor or heat pump circuit to the air handler. And that was kind of like the major lesson learned for me on the ducted heat pumps here. And then going on to smaller mini split systems, they can go to a smaller range, like around 0.75 tons, but also can go up to 5 tons. And they also operate in low outdoor temperatures, but will go even lower than the ducted heat pumps. And if you install them using no ducts, they avoid the duct losses that you might have with the centrally ducted systems. And one big benefit of mini splits are the zonal control that you get. So mini splits, they come in different versions as well. They can be ducted, but these systems are typically smaller than the first ducted systems that I showed. And one argument for having ducts is that you get better heat distribution. And also, since we're talking about retrofits, single family retrofits, they do have products that are 120 volt, meaning they can plug into any plug within your home, not just the 240 volt plugs. And some are DIY. They are pre-charged with refrigerant. So really all you need to do is, drill some holes in the wall to install it and install the fan coil. And then moving on to smaller HVAC solutions, we have window and through wall heat pumps. And those can be as small as like a 1/4 ton up to 1 ton. And these also have 240 and 120 volt versions, but they don't go to as low of outdoor temperatures. The Nova, for example, is a pretty cool product. It actually has 2 twin ducts that go through the wall instead of typically going through a window like these 3 products to the left here. The Olympia as well also goes through the wall, so that can have a more sleek design. And a benefit of this is having these products are having zonal control. And like I said, some of them can be a plug-in solution for lower cost electrification. And also talking about like a renter solution for HVAC are portable heat pumps. Although they are less efficient than the window and through the wall heat pumps, they are very portable and more affordable. And some can operate in low outdoor air temperatures. I know that here, for example, from conversations with the manufacturer, they can go below freezing, but with lower capacities. Now moving on to hydronic. So very similar to the mini split, look very similar, but they're heating water instead of air, and they are typically more efficient than the air-to-air products. Also, they operate in low outdoor air temperatures, and they can be used for pool heating, and then some are combined for space heating and domestic hot water. Like this AirMag product, for example, is a combined product for heating and domestic hot water. And this Arctic, for example, is marketed as a pool heating product as well. And they do make specific heat pumps for pools.
Emily,
yes. Yeah.
Could you return to that previous slide so we can just quickly respond to Stephen Keffer? Stephen, these are all examples of air-to-water heat pumps, and most of them operate up to 130 to 150 Fahrenheit, but that can be too low for radiators. So if you replace your radiators, there's ones by Jaga, J-A-G-A, Jaga, that are made for low temperatures down to 110 Fahrenheit. So you can definitely use any of these heat pumps with a hydronic system. The question is, do you get a really high temperature one so you can succeed? at like 160 Fahrenheit. And those are very limited. Usually you'd go to 150 and then put electric resistance for the last 10 degrees, which is not inefficient, but that's what you do. Or replace your radiators while doing this work, so you get the same comfort in the exact same place in your residence, the retrofit, right? The radiators are the same space, but it works for electrification. So those are your two answers. Thank you, Emily. Go right back to it.
Yeah. So pool heat pumps, they do make heat pumps specifically for pool heating, and they go up to like much higher capacities, like this AquaCal product to the right here. We're currently nailing down more products that go to lower temperatures, but like shown before, some of those products do go to low temperatures, and this Arctic one specifically made for pools goes down to 20 degrees. And more on HVAC, we have geothermal systems. They are very efficient, but high upfront cost, mostly applicable in cold climates where you have a lot of heating. And they operate in low outdoor air temperatures. And a lot of these can be used for pool heating and combined HVAC and water heating. And I just wanted to mention these products because they're pretty cool. They're all-in-one kind of HVAC systems. They have heat recovery, they filter the air, and they have heat pump heating and cooling. However, they're most applicable to smaller apartments and small homes. And a few of these products don't actually have a low temperature cutoff, so they can operate in colder outdoor air temperatures. Now moving on to water heating, we're going to focus on the individual heat pump water heaters. So most of these systems here are hybrids actually, so they're heat pumps with electric resistance backup. And you want to avoid electric resistance as much as possible because it uses about 3 times the energy. And typically what we've done in some of our projects is locate them in a closet or garage space, so they're get the boost of slightly warmer temperatures and are more efficient. The Eco 2, for example, here, it does not have backup resistance, and it actually does not have a low temperature cutoff. And it has, as the refrigerant, CO2, so it's more climate friendly in that aspect as well. And another thing to mention about these hybrid products, they have different power levels. There's high power that are 240 volts at 30 amps, and then they have medium power at 15 amps. So both the Rheem and the Ultron are have products that are 15 amps. So if you're looking for a more power efficient solution, that could be a way. And so these are, again, with Westcott Water, there are retrofit ready individual heat pump water heaters that are coming to the market soon. And these are the low power option we'll discuss later on in the presentation. So that's using 120 volts and about 20 amps. And since they're 120 volts, you can, they are a plug-in solution. So, ready for retrofits. Rheem, latest news I've heard is Rheem will be available by special order in about April. And one thing to mention about these systems on how to get more hot water, or how to make sure you have enough hot water stored in the tank compared to gas systems, which have a higher recovery rate. And we don't want to use we want to avoid using electric resistance because it does use about 3 times more energy as the compressor. So different strategies for hot water, setting your hot water tank to different settings. You can set the tank to a higher temperature and use a mixing valve to avoid scalding to get more hot water. You can select a larger volume tank, and then lastly, like I mentioned, you can select a higher power option that's 30 amps. Now move on to cooking. These are induction ranges. So all of these will require a 40 amp circuit. And, they have lower cost options up to very fancy retro induction ranges. And there are some with irregular sizing as well. I don't have them in this presentation, but if you were looking for more of a non-standard size, I think there are some out there. But there are definitely ones in the standard size going as low as $1,000. And moving on, another option for electric cooking is electric radiant. You get the benefits of the easily cleanable surface, but are more affordable. But again, requires a 40 amp circuit. And moving on, so a renter solution will be using countertop options. The one burners are about 15 amps and 120 volts, and then the two burners are 120 volts as well, and they are 20 amps. And I have seen case studies before that use two of these in a kitchen, which can be pretty cool. And then the larger countertop or drop-in induction cooktops are 30 amps and higher, so not plug-in ready. Now going on to dryers, there's a few different options for dryers as well. There are standard dryers, condensing, heat pump, and combined washer and dryers. So condensing, heat pump, and combo dryers are roughly 1/2 to 1/3 the energy use of standard dryers. And heat pump dryers, some have backup electric resistance, and they happen to be more efficient than condensing dryers, and you can get them with larger volumes compared to some of the other condensing and combo washer dryers. And then the combined washer dryers are very, very efficient because they are, and they do have two machines combined into one. So it can reduce your energy use even more. And moving on beyond the main loads of the house, important to mention are the power sharing devices, just kind of like, a main focus within our guide and showing different, home options that, are more power efficient than the others. You can use these power sharing devices. And they come in two major options. They're either circuit splitters, or there are some that will monitor the whole home and power share based off of that. The four to the right here are circuit splitters, and these two on the right monitor either an apartment or your home. They can be plug-in or hardwired, and you can set them up to split between different options. The NeoCharge, for example, has an EV to EV. You can plug in two EVs to one plug, and then when one is fully charged, you can charge the other. Or it has the option to have continuous power to both devices. But these will work for any other large appliances like dryers, your range or your cooktop, and your water heater. And like I said, they can be on or off or continuous between two devices. And then moving on, this will be kind of more of a speed round going through some of the other good stuff in the product guides. I did want to mention vehicle to home charging and vehicle to grid chargers. They are soon to be released in the United States, but they're very available around the world. A few of the companies are Wallbox, Osseco, and Redwood Energy. Yeah, so moving on to low cost resilience. These are pretty cool. Like if you were, these smaller products will charge your phone a few times, charge your laptop, but you can get them even bigger, off the shelf kind of electric generator solution. And a few of these products do actually come with solar panels. And I know they make a few products with batteries built into them for backup. I know Sean has mentioned before a refrigerator with battery backup as well. Moving on, Another strategy we've been looking at is using high efficiency cookware, basically insulated cookware, and how much you can save versus, standard cooking. And we did a little study on that, which is described in our guides. And then going along with cooking and the new California proposed requirements for ventilation, there are hoods out there that are quiet and quiet and meet the CFM requirements. And I think last but not least, electric fireplaces. These are pretty cool. They are using water vapor, so they look like real fire. It's not just an LED screen. And yeah, Optimist is the leading manufacturer of these, and then A Fire Water is another popular brand as well. And with that, I think I'm gonna send it over to Tom to talk about the Watt Diet.
Are there any further questions in the chat here? Just want to make sure that people have got their stuff. So I've been chatting back and forth, but does anyone have anything else you want to put in right now? David actually asked, Emily and Sean, window air source heat pump HVAC for tiny homes work off grid. So can we run these little heat pumps off grid? Yeah, they have low power demand, and that's the main problem with batteries, is having power spikes. So if you have a low power demand, then they run fine on batteries that are, what you need for off grid. Jean, pardon me, says, will we be able to get these slideshows? Yes, we're going to send out the slides after the presentation to all the people who registered. Yeah, Mary, want to make sure you hear that. We were showing, Emily was just showing the cold climate heat pumps, the ones that go down to -15 and -30. So you can see the booklet is designed specifically to make sure that we don't recommend anything that causes anyone a problem anywhere. There are lesser quality products that don't go to as cold of temperatures, but I think, especially in the era of polar vortexes that afflicted most of our country, thankfully not the Bay Area, but that it's right for people to just plan for the extremes of climate and get the product that fits that, and no drama going forward. And there's a Steve Pierce wants to know, does a power sharing device void the warranty on the devices like heat pump water heaters? No. What a power sharing device does is turns off the heat pump water heater if it gets to be using too much power, which is a standard function of heat pumps. We've been testing them for years with the Insteons. Water heaters going back to the 50s were controlled with on-off switches to prevent them from operating during grid-constrained hours. So this is 70-year-old technology. Heat pump water heaters are expected to follow the same rules as any other water heater. And we are recording this. We're going to put this up online on Redwood Energy's YouTube site, Mark Fernandez. So if people want to watch this again or share it with other people, it's there. It's on our YouTube site. You can just type in Redwood Energy into YouTube and you'll find us. Okay, Tom, let me let you take it away.
All right. Well, thanks, Sean and Emily. And as Emily showed us so many great devices there, folks are probably wondering, how can we fit all those wonderful things on our electric panel? And so, Emily, if you could advance. Mm-hmm. We'll start talking a little bit about that. So the basics of fitting things onto the electric panel, there are two issues. One is just the physical one of pole spaces, and that can be handled by doing things like having a little sub panel, or there's some of the circuit sharing devices that help you get two devices served off of one set of poles in the panel, and a couple other tricks like that. There also are thin breakers that called tandem breakers that you can use that fit more circuits into the same physical space. But mostly in what we call the amp diet, I'll be focusing on what are the techniques for choosing equipment and systems and control strategies that help you get permission to load it all on your existing electric panel. And I'll be using a 100 amp panel. That's a common one here in the Bay Area, common size for the smaller panels. And then the other new common size for new construction is 200 amp panels. And an ampere is a measure of current flow, and a 100 amp panel can let 100 amps of current flow through it at 240 volts. That amounts to 24 kilowatts of power, simultaneous power. That's like, I forget, 32 or 36 horsepower. It's a substantial amount of power. I noticed from monitoring my all-electric house, it's I only go up to about 4 kilowatts. so there's space for living large on these panels. So what the National Electric Code, NEC, looks at in panel sizing, they kind of write it out in a complex format. So I tried to simplify it here. The basic issue is you count the load in watts, and a lot of us are comfortable with watts for power. And they assume 3 watts per square foot of conditioned space for the general light and plug loads. So all kinds of portable devices you're plugging in and pulling out, like lamps and other things. And then another 4,500 watts of circuits that are defined in the code. 2 of them are countertop circuits in the kitchen for doing countertop cooking, and then a washing machine or laundry circuit. And so then beyond that, we start looking in the code, they look at the rated watts on the nameplate of the attached equipment. And so attached equipment is things like water heaters, furnaces, heat pumps, but it also includes the dryer, and it would include the range. So those are the types of things we're going to look at. And what the code says is the first 8,000 watts of that stuff that you count is counted at 100% coincidence. That means it occurs, at the time the building's having its peak load, that they've assumed, well, the first 8,000 watts is going to be on there. Beyond the 8,000, the first 8,000 watts of things you've counted around the house, they assume that stuff will only be on, there's only a 40% likelihood that that's on. So we don't make you upsize your panel just because you happen to own this stuff. It doesn't all run at once. So they use a 40% coincidence factor for that. And then the one exception is the larger of either the heating or cooling load. So if you're using the heat pump, we just count that fully as being 100% coincident. And so that's why when you look at the amp diet section in the guide and also on the Redwood Energy research site, you see us go into the watt diet method, and we really focus in on heating because you can get a lot of leverage off of improving your heating, both in the coefficient of performance of the machine and picking a better machine that doesn't use resistance backup in the heat pump. So anyway, you do see us focus a lot on heat. Okay, now we've gone through steps 5, 6, and 7. Then the 8th one is, okay, sum up those first 8,000 watts plus 40% of everything over that, plus the heating watts, divide it all by 240 volts. And that equals the number of amps of counted load that you have on the panel. And so that must be, for a 100 amp panel, that must be equal to or less than 100 amps. So it can be 99 amps and that clears, or 99.5 or 99.9. They all clear, and you can get permission to move forward with your existing panel in those cases. People bring up these 80% rules, and those apply. 80% rules for circuit sizing applies to some long duration flow circuits. We often see it in like the heat pump, the EV charger. And so that circuit needs to be a little bit larger than the rating on the EV charger, because the EV charger can run for long hours. And if you can advance.
Tom, before you advance, Pizza Hervanen wrote, continuous loads are considered anything running more than 4 hours. There's a comment. Do you have any comment or any response to that comment?
Right. And so what I've heard is anything running more than 3 hours. Okay. When I looked at the code recently, but yeah.
Okay, so I guess the comment was to make sure that your math here and your layout was complying with the NEC code, and you're confirming, yes, even a little bit more conservatively than what was just commented.
Mm-hmm.
Thanks.
Right. All right, and Emily, ready to advance? So, basically what I was trying to get at is we're looking at the physics, and we're trying to get permission to stay on the panel. So reading this diagram from the bottom up, lots of us are in the energy field, and we think about this on an energy basis in the lower right. We're thinking about the device energy usage, and that's interesting, but not the real critical factor for us in panel sizing. For us, it's more the power in the bottom middle. So we're looking at what is the power usage of the device. And so you'll hear Emily and I sometimes talk about power efficiency, and that's looking at a device that is able to do its job without hitting a high power need. And so it's able to do it at a low power level. And so looking at the row above, we tend to look at equipment in the nameplate rated power and the rated amps. And so that's where it will move up and be operating, and where they think it's going to operate at its full usage. And so these kind of things we look at them count in the counted additional box there, and to the left you see the already counted. When I mentioned that thing about the first or 3 watts a square foot for lighting and plug loads, so that stuff's already counted. Also, kitchen countertop loads are already counted, things like that. What gets counted additional to those loads are things that are attached. And so one interesting attached example is, let's say you have a 1200 watt microwave. And if it's a countertop microwave, it doesn't count as an additional load. But if you screw it to the wall, it is now an attached load to your house, and the code counts now 1200 more watts of attached load. And then it would be multiplied by its own coincidence factor. Let's say it was beyond the 8,000 watts, so it was a 40% coincidence factor, so it's 40% of 12,000 watts, so a little more than 400 watts. So that's an example of interesting things about what does attached mean, and when does it apply, and then what is coincidence. But we basically total up the already counted, the additionals, multiplied by their proper coincidences, and we get the total counted watts. We convert it to amps, check it against the panel rating, and that's how we get permission to operate with that panel, or whether we have to move up to the next size panel. And electric panels are sold in increments like 100 amps, then 125, 150, and 200 amps, and 225 amps. So they come in these integers. The whole point of trying to stay on the existing panel is to really avoid the upsizing expense for yourself, and the time it takes, the weeks you may be waiting in line to get permission to do this, and the complexity of the project, because we're trying to figure out how to keep people from hitting stumbling blocks. And so looking at the amp diet, it's a way to limbo under the requirement. But what we're finding from talking to a lot of folks is so many tradespeople and even the utility people, they all give advice of always upsize. And it's like asking your barber if you need a haircut. And the answer is, of course, if you're willing to ask, the answer is always yes. And so the amp diet is kind of looking at it a different way and just seeing, what are the rules? What's reasonable? Can I fit it all together, or do I have to follow these people's advice? And it's often, when people go and ask for the advice, they're getting advice that serves the interest of the electrician or the utility. And the utility will make money by upsizing the whole total system, and the electrician gets a bigger project. So, we need to start looking out for our own homes and our own panels. And Emily, if you could advance.
One thing I just wanted people to know, I'm putting the website, your Watt Diet work, right? Our collaborative efforts. Watt Diet is at redwoodenergy.net/research. So I'm putting that in there. Just scroll down a little ways. And this is Tom has done an amazing job of creating a very large calculator that encodes all of the National Electrical Code into it. So you don't have to know all these things. It's just built into the spreadsheet. So you choose little drop downs, and it helps guide you towards all the different efficiency options that he's just about to show here. So just so you know, if you are willing to spend a little bit of time playing with it, it's there for you. Okay, take it back.
All right, thanks, Sean. So now this graph is really going to try to show a little bit about the counted watts situation and it includes the coincidence factors already applied. And so looking at the very bottom of the graph, you can see scale of watts, and it goes to negative 4,000 and positive 13,000, I think. And so these are the counted watts in the panel, or panel watts. And so we've broken it out by several categories. Top category on the page is the space heating category. And so things like that window plug-in heat pump, and I bought one of those after reading one of Sean's early guides. I got one of those, and it counts as 0 watts because it's just part of the first, the 3 watts per square foot. And so it doesn't load onto my panel sizing calculation, so the building department won't make me upsize. And then, the next bar up there is a mini split single zone, and then a bigger, that was a 1-ton mini split. And then next up, we see a 3-ton mini split going up to counting about 4,000 watts. And it just depends on the efficiency and, which is really related to the quality of the device you're buying. Look at the nameplates on them, or read the guide, or check out the NIA site for the performance of these heat pumps. And you can find some variety in there and pick the better brands and models that have the lower watts at your design temperature. And the Watt Diet site helps you do that. And then you see the giant bar over there, that's the problem. And that's when you use a central heat pump with resistor strips like they used to have to do in the old days before they had inverter driven compressors with microcomputers in there that are really controlling the motors and putting it through sophisticated routines that keep it defrosted and keep it operating at low temperatures and producing good results. So you don't need to back it up with resistance, especially in milder climates like I'm here on the California coastal area, Bay Area, and we don't need resistance. But lots of tradespeople still remember the old days when heat pumps used to need resistor backups in mild climates, and they don't anymore. Anyway, next one down is heat pump water heaters.
Tom,
We've got
an urgent question. Eric Wolski is asking, can you please distinguish between the NEC 220.83 for retrofits and the NEC 220.82 for new builds? He says, my electrician and others I've heard from are using 22082, which is for new builds. It would be nice for people electrifying their houses to be able to speak intelligently to their electrician. So I guess it's 220.83.
Right. So, yep. Yeah. So I'm going to have to look further into the 0.82 versus the 0.83 sections of the code a little bit more on the differences to see what it is. But there are a couple of different code sections to look at this, and the one I'm using here is retrofit, including adding space heating. And so, which is where we are when we're trying to retrofit and head towards full electrification. But I will get to that. It's just a new construction question. But moving our way down through water heaters here, we can see these upcoming new products that a bunch of us have been working on, the 120 volt heat pump water heaters. They'll have a real low panel draw, about 360 watts on the panel versus the 30 amp version, the very common version, which is, counts as more than 2,000 watts. It's a 4,500 watt machine, but it's only counted at 40% coincidence. Anyway, you can see the span of options available, is about as wide as some of the other things on the heat pump water heaters. Then you can see a number of cooking situations. The thing that was unintuitive to me was wall ovens. If you're remodeling your kitchen and you can use a combined range where the oven is under the cooktop in a slide-in appliance, they have internal power management in those things that's just normal. And so you can save a whole lot of amps in a remodel by using a range, combining oven and cooktop, versus like I did the wrong thing. I went and put in wall ovens, 2 of them even. And so that really raised my total amperage count. The other thing is this interesting zero in laundry. Look at the 0 listing there for combined washer dryer, or combined washer and condensing dryer. So that's the thing Emily was talking about. One machine, you put dirty, dry clothes into, and it gives you clean, dry clothes out of the same machine without hurting your back in between. And so that machine is interesting because it lives on the laundry circuit, which was already required. So here you've done your drying without incurring any additional amp load on the panel. And then the next 3 bars down are showing heat pump dryers, condensing dryers, and then regular old resistance electric drying. And then the next one, electric vehicle charging. The 0 is just plugging in that 110 volt or 120 volt EV charging cord that comes in the trunk of your EV. You just open the trunk, get it out, plug it into the garage socket. It doesn't count on your electric panel sizing. That's just part of the general loading of the house. It's not a new counted thing. Then the next 3 below it are level 2 chargers, the 240 volt chargers. You can get them set at different levels. So they have different panel loading. And that's choosable by you. So you could choose a mid-range charger instead of a high-range charger if you needed to keep from exceeding your panel capacity. And the final 2 at the bottom are these showing examples of the automatic circuit sharing systems. The top one is the ACS, this like a NeoCharge circuit sharing, and then the bottom one is a whole panel monitoring system like the DCC9 that looks at the total panel load, and it just pauses the EV charger if the total panel load got up over 80% of the panel rating. And so, for example, if you were charging your car and cooking and a big party going on and everything's happening, you got up over 80 amps on the charger, it would pause the car charger and the party would go on. And then later, when the cooking's done or something, the car resumes charging automatically. And next. All right, so a little bit of, more details. I love graphs. Okay, so this one, it's the kind of thing you may want to look at on your own in the guide, but it's relating the seasonal efficiency, these essentially equipment performance factors for how efficient the equipment is, and just showing that we can get different amp ratings or different amp usage levels for different equipment. And it matters, which, how efficient it is, and then it matters whether you're able to go ductless or ducted. And so we can improve the overall efficiency right there. Let's move on to the next. So this one, the bottom axis is design temperature, meaning how cold your climate gets. And I live in the Bay Area, so mine's at the far right, the 30 degrees Fahrenheit. And other places get a bit colder. And so we can see on the right-hand axis, the heat pump running amps. And you can see that as you get into a colder and colder climate, there are a little more running amps on these heat pumps. And then the main thing, the difference between the 2 lines, for example, is whether your building is tight or leaky for air tightness. And so tightening up your building can let you go and pick a smaller heat pump and then have a lower amp load on your panel. And next. So here's an example picture of what a panel may be able to look like. I like working in spreadsheets, but this is just drawing it out more the way a panel looks and applying a little bit of the information to the sides. So you can see the circuit sizes are in the far inbound, the 15s and 20s at the top, and you see a couple of 20 amp circuits at the bottom. The double wide circuits at the bottom, those are all 240 volts, and that's how your panel tends to do it. It uses double wide circuits to be able to pick up the other poles and get up to 240 volts. And anyway, this diagram will take a little offline study for folks just to see. It's an example of what you might want to be able to draw up to show your electrician what you have in mind after you've figured out that you want to try to use your existing panel and fit everything on. Here in this example, we've got a 2,000 square foot house in the Bay Area fitting on a 100 amp panel, going full electric. In the bottom left is putting in a 5.8 kilowatt solar system. And in the bottom right is using a 15 amp heat pump water heater. And then we used a 20 amp heat pump for space heating and cooling. And next. This example is to take it a little further. That prior one was 2,000 square foot house. We thought, okay, let's see how far we can go with this calculation and this method. So here's another Bay Area house, 100 amp panel, 3,000 square feet, and then checking to see what do we have to do to stay on the 100 amp panel. And what we had to do, we had to go to a ductless heat pump, 20 amp ductless heat pump, bottom, towards the bottom left, second from the bottom. And we had to go ductless to really get all the heating we needed. We couldn't afford the heat loss from ducts. But then on the right side, we had to do circuit sharing. And since we were doing circuit sharing with these automatic circuit sharers that alternate which device is getting power, the second from the bottom, it has the resistance dryer and a heat pump water heater. And so while the clothes are drying, the water heater pauses and it waits to finish its recharging itself until the clothes are dry. And in the far bottom right, the range and an EV charger are taking turns. So while dinner's cooking, the EV, it was supposed to wait till midnight anyway, but it just can't get any power at the same time the dinner's cooking. And then later it can get power. So that's an example of really trying to see how far to stretch it. And next.
Hey, Tom, a question that Jack Fleck had was, how do I find out how many amps my current panel is?
Oh yeah, so that's in this diagram. It's kind of shown there in the upper middle. Frequently on a panel, there will be the main service line, and look at its rating. So this one in this diagram, you can see it says 100 on that upper breaker in the middle. Yeah, it's also printed on the inside of the door, and because some people have used a derated main feed breaker, but their panel could handle more. That'd be a case to talk to your electrician about if you've got that case. Often they, sometimes in solar, they would derate the main breaker so that they could feed a little more solar in at the bottom.
And relevant to this panel, Jeff Wicks of NIA, he wrote a little bit earlier to the panelists, and I encourage everyone to write to panelists and attendees. Set that in your chat so everyone gets to see your helpfulness. So Jeff wrote, for domestic hot water, water heaters, the retrofit ready 120 volt types that are becoming available, it looks like in April from Ream and others. He says up to a 700 watt draw is what they're estimating. Go ahead and put that in the chat if I misspoke there, Jeff. What you're saying is those retrofit ready heat pump water heaters are 700 watt draws.
Right, and you see where I showed it on the, when I showed it in my chart, I was counting, say around 360. So I've counted it, it after the coincidence, because that horizontal chart I was showing was all about counted panel watts. So I was accounting for these roughly 700 to 900 watts on the 120 volt water heaters. And next. All right, well, thanks very much, and off to you, Sean.
Excellent. Okay, I'm going to start sharing my screen. Oh, there we go. Almost there. You stop sharing your screen, and I've got mine. Okay, folks. So I'd like to guide you through two basic options. If you don't have much money, and if you got plenty of money. I have not had a whole lot of money in my life. I'm still got 3 little kids, and I've got a farm that generally costs more than it brings in, and all sorts of things that have made me avoid. For instance, when I electrified my house, I could have put in a new electric range, but instead I've been playing with 2-burner induction ranges like this one, and also single burners. Although I like the commercial quality better when I'm getting a single burner. But then other people I've known have just gone out and gotten electric resistance cooktops, like these $18 and $30 varieties. These are all 120 volt, so they plug into any plug in your kitchen, and they don't use more power than what that plug is rated for, and all the rest of it. So it's totally safe, totally normal. They're just like a a toaster or a blender, but they cook all your food. And so as a professional chef previously in my life, as someone who just cooks huge amounts of food, and I've got 30 acres of livestock out there, so I have all sorts of crazy stuff come onto my my frying pans and ovens and such. This works great. I can set the temperature exactly what I want. I never have to worry about the food burning because the gas flame got too hot and I walked away from it. Induction doesn't get hotter than 450 degrees, while gas flames get up to 3,400 degrees. So you can melt a pot walking away from it on gas or electric resistance for that matter. But induction doesn't get hotter than 450, 475, which is way sizzlingly hot, way hotter than you need for anything. It gets as hot as you need for cooking. But it doesn't get to dangerous hots like others do. Next one down here, this is a whole range of countertop devices, crock pots and Instant Pots, because of their insulation. Not because Instant Pots have pressure that accelerates cooking, but slow cookers, both of them, because they have insulation, use 1/4, maybe 1/3. We've been testing this for all sorts of different devices. You can say authoritatively 1/3 to 1/4 of the total energy if you're cooking in the insulated. So 3/4 or 2/3, it's not being lost. Or definitely use 3 times or 4 times as much energy cooking on your range as you do in an Instant Pot or a slow cooker if they've got insulation. So it's a huge energy savings, as well as power savings, because these are all 120 volt, like 900 to 1200 watt, 1400 watt devices. Okay, Presto stainless steel electric wok, $80. You can get specialized induction woks that are like for restaurants and such, but definitely in like the $1,000, $2,000 range for some really nice stuff that will last forever and ever, and it's, you know, for all night use in various restaurants and such. But if you just want an inexpensive wok that does exactly what you want, you can get electric woks. This elite combination oven griddle steamer you find in restaurants as well as at home, that electricity allows you to use the same device in a lot of different ways. Where does the heat come out? How controlled is the temperature? Does it involve steam? Does it involve, so there's opportunities there to get an inexpensive combo product. The griddle is right on top there underneath that, and that's also the steamer versus there's the rotisserie, and that's nice. Cheap little oven can do a rotisserie chicken in it or a gyro. Fantastic. And then this is my oven, the Oster. I love it. I can get all sorts of wonderful things coming out of it, and it's $160 and it plugs into the wall. So what I did is I took out my fancy 1950s era insulated gas range, the chambers I hunted down and dragged out of a field, and it was poisoning my whole family. You know, carbon monoxide, formaldehyde, nitrous oxides, and where that was, I put in like a just metal shelving, and so now I've got a lot more storage, and I have the oven there, and I have that 2-burner range on top, and off to the left of me is where my wife does her yogurts and things, because induction can be controlled to like 140 Fahrenheit exactly, and you can do all sorts of higher end cooking on induction because of the temperature control and then the immediacy of its response. Okay. Once again, focusing on inexpensive options and why you might like them. Electric resistance heaters are silent, but you need a really decarbonized grid to use them without being ashamed of causing more pollution. As soon as you move over to a higher carbon grid, then you want to go to a heat pump. And this winter here we found is about 52, 53 decibels, so reasonably quiet. It plugs into the window, so you don't need to actually stick it in a window. There's just 2 little ducts, and you close the window on it. It's like 4 inches tall little plastic piece with 2 ducts in it. Now that's not super efficient, but it's a heat pump, so it's reasonably efficient. You can get them to go down to about 20 degrees Fahrenheit. Nate Adams, Energy Smart Ohio, does electrification. That's how he heats his own house. In Ohio, by Lake Erie, where it is beastly cold. I went to college there for a year. Holy moly. So they work, but his wife has told him, even though you're Mr. Electrification and this is cheap, you know, $400, I want something that's quieter. This thing's too noisy, which they are at 52 decibels. It's like a dishwasher running all the time. So moving over here to Mr. Cool. It's 3 times as expensive. It's producing about the same amount of heat, but it is silent and it'll go down to crazy cold temperatures, Like this can go down to -15. This can't go past about 20 degrees Fahrenheit. So Nate over in Ohio was using electric resistance, just strip heaters in his house, paired with his heat pump. So he had the ability to deal with your extreme temperatures and such, which happens. But this can do it all at once. So Mr. Cool, this is the do-it-yourself version. You know, comes with everything you need. So you have a couple of wrenches, and I think Tom, you actually install this in your own house. But Tom's an engineer, as you might have guessed. So here is an easier, more expensive version of the same thing. Innova, also one made by Olympia that you can get on Home Depot. Innova, you have to like get through the distributor and such, and it seems to cost more money than this price tag, which is what they sell to the developments that I support. Those are like bulk and such. So anyway, Olympia, Innova, both these are heat pumps that sit on the wall. Put 2 6-inch ducts through the wall. So just ducts, just like the Winter over there does it through an open window. This does it through holes in your wall. Put little like vent caps on the outside. And this once again can run to like -5 degrees Fahrenheit and still be putting out heat. So you can have a polar vortex and still have a warm house with this heat pump. Down below, and hopefully someone else is keeping track of chat. I can't do chat obviously and talk at the same time, but please interrupt me if you see questions, Emily, or anyone else that would be helpful to deal with right away. Okay, on the bottom, 7 gallons is all you need for a single shower with a 1.5 gallon per minute shower head. So this is in our tiny house bathroom. I have 4 tiny houses here with farm worker housing, really high-end tiny houses, cedar shingle, wool insulation from our farm, gorgeous hardwoods, all that kind of stuff. And I'm running them on a 30 amp circuit off the machine shop where we have all the freezers and the baby piglet warmers, little heat lamps with the mama and the piggies. So we have this 30 amp house. We run it with a 7 gallon and it's a little tiny house bathroom separate. Then this 19 gallon, this is what you could have for 2 people. You're not gonna necessarily get 3 out of 19 gallons, but you might. Then 30 gallons, that's assuming you have a low flow shower head like the Evolve, which is fantastic. It also has a thermostatic valve, so you don't waste the first minute or 2 of hot water when you're like waiting for it to get hot. And then this is how people actually behave. You wait for 1 minute to get hot, and then I've studied, I'm not joking, more than 100 households now, and I can say for sure, people spend another minute not getting into the shower while it's hot. On average, a whole minute of hot water going down. So an Evolve with a thermostatic valve, which I've been showering with for 12 years, and it's awesome. I have many versions of it, they're all awesome. That's gonna save enough water with the 1.5 gallon per minute shower head to get lots of showers out of even 30 gallons. The 120 volt next to it, these are all 120 volts, retrofit ready. 40 gallons and 50 gallons is what they're selling. These are 120 volt, 700 watt or less. One's going into my house shortly, and we're just waiting for the plumber to arrive. And very excited about that because they're essentially an appliance that can plug into any outlet in your house. You just need to, have any outlet. And things are cool. No extra rewiring. And notice the sort of the seductive draping of the electrical cord. You never see that on a water heater. Them like showing off the cord in some decorative way. Crack me up. But that's the advantage of this one, is you can just plug it in. Induction ranges, which I'm a big proponent of because they're so high quality. Yes, electric resistance ranges are about $500. So if you want to get out a nice smooth top, not the coil type, a smooth top, resistance range, $500. All sorts of different brands do that. But just focusing on induction for a moment, the smaller 24 inches on average, this X here, about $750. 30 inches and 36 inches, they're the same price, but you can see how the range goes up because 36 inches is more of a luxury type. 48 inches, you're talking like instead of $2,500, $3,500, $4,500. You start getting into like fancy old big 5-6 burner ranges. Tons of those exist in the booklet. You'll find ones that look like they're from 1930s, but have a fantastic induction range on the top and such. All sorts of like fancy looking ones. But now you're talking $4,000 to $8,000, just like you'd spend if that was the gas range. But here, this is what normal people should think about: $750 to $1,500. My mom, who's retired and bakes all day, and brought me a cookie earlier. She lives next door in one of the tiny houses. She bought this $2,200 double oven fancy blue enamel inside, 5 burners on top. I think that it's by KitchenAid, which is important. They for a long time have made high quality kitchen implements. And you always get a warranty on anything with a computer. Anything with a computer in it needs a warranty. So this has not failed, but that is the basic problem I find with anything with a computer, including induction ranges, is that computers are not reliable inherently, and you should have a warranty for anything with a computer. Okay, here's me. I'm so delighted. This is my first load of laundry in my sister-in-law and brother's condensing washer dryer. I purchased one just weeks later, been using it. It's a plug and play that's talked about. You can just stick it in, it washes and it dries. Now this is a nice one. So this is a $2,200 one, once again. But it'll text you when your laundry's done. It'll text you if there's like the filter needs to be cleaned. It's a smart device. You can time it in all sorts of different ways. It's optimally grid friendly, and it's big, 4.5 cubic feet. But just generally what you're looking at with a combination washer dryer is $1,200 on average. But they're gonna be smaller, like 3 cubic feet. Heat pump dryer, those come in all different sizes up to 7 cubic feet, which is sort of like the biggest of all dryers. So there you're seeing like, $1,300. Condensing dryers, which are less efficient, and are often smaller, but just a condensing dryer, those are in like $1,100 range. And you might find a condensing dryer that's 120 volt. You're not likely to find a heat pump dryer that's 120 volt. And these combination washer dryers are condensing washer dryers. So they are usually 120 volt as well. It's just the heat pumps that are going to require that standard 30 amp 240 volt circuit. These other ones, you just plug them in anywhere. And this is my last slide. This is from Energy Smart Ohio. We paid them $1,000 or maybe a little more just to give us these 9 bids broken out. So I want you to appreciate this. This is a highly detailed, real business that does this. In the green, that's what Nate charges for project management. He doesn't do any of the contracting generally. In gray here, this is him going around and insulating the building, tightening it up, making it comfortable. He feels like he sells comfort. He has a whole book on comfort. And so you can see that's a big part of his business is selling comfort. Makes sense in Ohio, famous for old, leaky, unpleasant living experiences. So yellow, that's domestic hot water, pretty modest cost. A lot of these people are putting in the water heaters themselves, it seems. So the cost is mostly just the purchase cost. In orange, that's ductwork. It's not necessary for all projects. It's actually for the minority, but there's sometimes, even often, a need to do some ductwork of sealing it or tightening it or finding leaks, etc., or just replacing it like you see in House 5. Just take it all out, start over. Then in blue, that's the HVAC. That's a pretty consistent cost you're seeing of like $9,000 to $11,000 for the HVAC system, and that is putting in the heat pump, not the new ductwork, but connecting it to the ductwork, testing it out, making sure everything works at the end of the day. So if you're electrifying your house, you might spend, like I did, more in the range of $6,000 because I used for everything, $6,000 to $8,000. This is, the whole package, including project management, that's about $11,000. And then for like the biggest of the houses, 2,700 square feet, with the most amount of envelope work, some big old house that was really leaky in Ohio, that was almost $50,000. So pick a number, somewhere between $2,000 and do it all yourself with the equipment that I showed you up here, right? This is you can have a $2,000 retrofit using the high-end stuff here. Not high end because that'd be all 2,000, but the heat pump water heater, say like the winter, just for your house, and a couple of these, like the range and the oven, you can get it done. I'm not saying that that's as nice as what I've also been showing you. I'm just saying you can get it done for a couple grand, or for $6,000, or $10,000, or $50,000. Pick your own adventure. Okay, so I'm going to stop there. I'll take any questions over in the chat. And you, Mark, you want to know what kind of insulation do they use for the envelope? It was a mixture of foam insulation that was sprayed, sheet foams I've seen on the outside where we'll take off the siding and put in sheet foam insulation. So it's a lot of foam. that he uses there. And Jeff's like, we converge induction, never look back. Heck yeah, why would you look back at old bad quality cooking experiences compared to awesome? Yeah, Joe's saying, hey, do not rely on the shutoff valve to stop the gas flow. You must cap or plug the gas line. Yeah, like have them come with the Sawzall and cut it off at the street like they did in 2017 at my house when I had an explosive gas leak in my front yard and I rapidly electrified everything that was left. Amy says, hey, what about knob and tube? So in my house, a 100-year-old house, we had knob and tube. We cut it off at the attic and replaced it with Romex from every place we could access. And then we put in LED lights, which use 1/10 the electricity, 1/10 the power. So they don't heat up the wires barely at all, like at all. You don't have hardly any power going through for LED lighting compared to incandescents. So with that radical drop in power demand, we just left the knob and tube and such where it was inaccessible in the walls and replaced what we could get at. And the electrician's like, yeah, that's safe. There's nothing wrong with knob and tube. It's just especially if you haven't been using it hard and degrading it. Are there rebates for induction ranges? Yes, but depends upon where you are, like what utility and etc. And I'll just try to take the rest of it and I'll hand it over here. So I think, is it Jonathan? Are you next?
I think so.
All right. Have I turned off my screen? I have. Okay, so why don't you try sharing your screen? Oh, there you go. Hey, Jonathan Moscatello, the heat pump store, co-owner, hero, an international expert. I kid you not, an international expert on heat pumps. We are lucky to have him with us today. Thanks for being here, Jonathan.
Oh, thanks for having me. It's really actually a refreshing end to my work week to be among the tip of the leading edge in doing the right thing. And I want to commend you, Sean, and your team on putting together the enormous handbook. And one thing I noticed about it is that it's chock full of these great approach to it's got a very appliance focus. And I want to talk about my favorite appliance with you all today because I'm passionate about it. I love heat pumps, and I don't know why. I mean, I didn't grow up hoping and planning to be a heat pump expert. I think like so many people, I just found myself doing it. I wanted to be a farmer, and I worked in agriculture, and then I saw heat pumps. I knew global warming was real and electrification needed to happen. And so in 2007, I became a contractor and I started selling heat pumps in homes. And then by 2009, I took a little deviation, which was kind of a big mistake. And I went to work for a manufacturer of heat pumps and it just wasn't right fit. Like, I'm not a corporate guy. It's just not who I am. And so in 2011, my wife and I decided to join forces with a couple who started a ductless heat pump only contracting business in 2007, and they just needed help. And so in 2011, we bought that business from them, and we still kind of work together on it. Now, in all fairness, my wife owns and runs that business. It's a woman-owned contracting business. And
hey, Jonathan, your screen is blank white. Are you intending just to speak to us?
You know, that's interesting. I have animations, maybe, let me see. Oh, I think that's
there we go.
Zoom meeting.
Sorry about that, y'all. Thanks, Jonathan.
Yeah, no worries. So my wife owns and runs this contracting business. I help out, but my real job day to day is to go around the country and try to get contractors to do new things. And that's what I want to talk with you guys about, is like this, how hard it is, not because it is hard to go, all electric in your home, but you don't have quite the teammate in the contracting space that I think you should. And so, I go around the country and I do this thing called Growing Ductless, which is about getting contractors to take this opportunity seriously from a business standpoint, but also from a technological standpoint. And then I also run another program called Heat Pump Nation. And so I just thought I would share a little bit of the journey and see if anything resonates with you. When we started this heat pump only contracting business and grew it, we had friends in the contracting industry tell us, don't do it, you'll starve. You can't do a ductless or heat pump only contracting business. And I think I'm happy to say that we proved everyone quite wrong, because of a couple of forces. Like, electrification is real, but equally real is that homeowners want new and better technologies for their home. And in Sean's handbook, you're seeing the cutting edge of all this great, wonderful technology for homes. And it happens to be an they're electric appliances. And so isn't that exciting? Like, we get to remove, carbon emissions from our homes, but we also get to have wonderful, modern, comfortable, better technologies in our home. And I'm here to tell you, from a business standpoint, there's a real opportunity for people to have businesses around doing this work. And that's pretty cool. I recently saw this graph. I think most of you probably know it, but in the home's kind of greenhouse emissions, budget, let's say, space heating and water heating are the kind of biggest contributors. And when I see that, I get really excited, because I think, wow, it's totally doable to change the space heating to heat pumps. And I don't care where you are, and anywhere in the United States, even in places, well, there's places in Alaska where it's probably not feasible right now, but in the lower 48, it's totally feasible. And what it involves are, on the left, I work primarily with ductless style heat pumps, and I have a thought to share with you all on that in a minute. And then heat pump water heaters, right? That's it. These appliances are viable, they're real, and it's not a big deal, right? To in my experience, to convert your home to these technologies. And so, yeah, we've been doing it, at least at our business, since 2007, and we've converted over 20,000 homes to heat pumps, and it's worked well. It's contracting business, which is a kind of crazy business. It's not very easy to keep all the moving parts going and not charge people an arm and a leg to do something, but we've made it work, and it's been pretty exciting. Now, I thought I'd just kind of share some thoughts, right, about this for you. So what have we learned so far? Well, number one is that converting a home to a heat pump for heating and cooling is really easy. But like most things, us human creatures can make it really complicated. And it doesn't need to be. So I would encourage you all, as you consider or advocate for heat pumps in homes, that a simple path is a better path for all outcomes. And that's a whole conversation. What is simple, right? Well, that's a whole conversation. The other thing that I've learned is that converting a home to a heat pump water heater is a little bit harder, but it's not impossible. It's just a little bit harder. And I can explain what that means, but largely it falls under the sort of auspices of, it just takes more time and a little bit more preparation to replace a water heater, for a couple of reasons, mostly electrical, but some other factors. Okay, so what other tips can I share? I would say copying others' successes is a really important theme. And so with that in mind, I would say, for instance, in the United States, we don't talk about this enough, that Japan as a country electrified with a tremendous amount of policy and effort in the 1970s. And that initiative, let's say, is where ductless heat pumps came from. And so it was a real success for Japan. And now this technology that they invented in the 70s is used all over the world. It's a fully mature technology. It's not, something that represents an experiment to try something new. It's used every day over the world, and it has been for 40 years. But here's the thing that I want to encourage people to think about. Ductless heat pumps are efficient in and of themselves, as well as the new generation of heat pumps. But in Japan and other places in the world, they go a step further and they live zonally within their home. And so it's the combination of having a modern, efficient appliance and then how it's used and applied in the home that produces the tremendous benefit of electrical savings, energy savings, as well as comfort. And that's a piece that we're not getting in the US, as far as I can tell, in our path toward heat pumps and electrification. And I think in your handbook, Sean, you do a job letting people know that there are heat pumps for centrally ducted systems. I would just think that I'm just not a big fan of them. And that's a whole other discussion too, but we can.
I have a mini split. I'm backing you up here. It's comfortable and silent and awesome. We're trying to make sure that people can do an easy retrofit also, and that can mean just using your ductwork.
Right. Yeah, no, I get it. And for some people that will be really easy. So good on you for putting it there. Another thing, and I hear this a lot from people living in California in particular, is that there's a lot of time and effort debating the existing home infrastructure and its deficiencies. And I just encourage my customers, like when we work with people, that there comes a time when you need to improve your home's infrastructure. Like roofs don't last forever. We don't drive cars from the 1920s, right? There are newer, better things. And it's just sometimes you got to replace the electrical service in your house. And to not sweat that, I think that there's a lot of homeowners we talk to that get anxious about the cost or about the process of getting a new panel and a new electrical service to your home. And I think that within that, I often hear an assumption that is misplaced. Homes' infrastructures don't last forever. They have a useful life. And an electric panel from the 60s that has a limited power supply and possibly even some bad wiring or circuit breakers, it's time to get rid of that. And just do it and move on if you can afford it, right? Related to that is I work on utility programs, and I love the way in the utility programs understand that weatherization of the home it's just common sense, right? I mean, you could put big heating and cooling appliances in, or you can put really small ones with some insulation and just not consume as much energy in the home. But we get hung up on, is it cost effective to do that? And we just get ourselves all turned around on that, as I would say that we as a contracting industry and other aspects of programs. And I loved, Sean, how you positioned it when you talked about it as it's a nice home improvement. It's comfortable to live in a weatherized home. And I'm here to tell you that's wholly my experience, my customers' experiences. And we just need to start looking at weatherization, which is important to a home's overall energy picture. It is important. And we have to sell it as, it's a nice upgrade to the home's infrastructure. You want to do it. Sure, it costs a lot of money, but if you can afford to do it, just do it. And then remove this cost-effective, cost-benefit relationship from it, because most people who do it and get over the cost of doing it are really happy afterwards. So, okay, so what barriers do I see? And this is my little attempt at humor here on a late Friday. I would say that overall, the barriers to electrifying our communities come from the fact that largely contracting businesses are generally conservative, and therefore they are not prone to innovation or change. It's just not a typical trait in the people that run those businesses. Also, the way contracting law is set up, there's a little bit of risk to be out trying and doing new things in people's homes. And so I think that contributes to the lack of typical innovation behavior traits in contractors. Similarly, or in another barrier, not similarly, I would say, but possibly another thing to consider is that most homeowners are woefully inexperienced with their home's operating systems. And what that means is they generally don't know how to talk about things like electrical panels and services and HVAC and just other aspects of their home. It's just not something they have to talk about with any regularity. And I think that this combination of factors, as simplified as it is, right? It doesn't seem like it's really a big deal, but I mean, I go in homes all the time and try to communicate with homeowners, and it's hard. There's a lot of miscommunication. It's like contractors are from Mars and homeowners are from Venus. And so when you get a contractor who might not be very innovative or on the cutting edge, or might not even believe that global warming is real, and you get a homeowner who wants to do these far out renovations of their homes, it's just really hard to, it's really just a recipe for frustration. And so I know it's such a simple way of looking at the world, but I feel like, you know, contractors are out there, they've got to largely do the work to electrify our communities. And, you know, homeowners, you know, you want this, but like we have to get our conversations happening better, because contractors aren't even really yet talking about, for instance, heat pumps to the degree that they should be. And until they do, I think that there's just not going to be as many heat pumps installed, and which is a shame, because we could be largely eliminating gas furnaces in most of California, I think, for right away. It's just not that cold in California. There's no, you know, we don't need furnaces. And contractors are in a great position to talk with homeowners about that option. They just aren't doing it today. So anyway, I think that's really, I'll leave it at there for now, and just look and see if there are any questions or thoughts that people might want to have me talk about.
Awesome. Well, thanks, Jonathan. It looks like Sean dropped off. So, yeah.
So Jonathan, I do see a question from Misty Burseri about why don't you like ducted systems?
Well, first thought is that ducts leak. And in most parts of the country that I work, ducts are out, because we jokingly say ducts are outside the home, meaning that they're in attics, which are an unconditioned space, or a crawl space. And so the combination of leakage and then the fact that they're in the outside of the house just means that right off the bat, we're losing, on average, it's been shown 35% of the energy. And then on top of that fact, most people don't live in all areas of the home. And so, you know, conditioning the home to a same temperature, even when you're not in those rooms. I mean, America is pretty much the only country that does that lives that way. Other countries, to great extent, save a lot of energy in living zonally. And ductwork by its design is really not a zonal solution necessarily. So that's kind of the just short answer to that.
Yep, and then Emily and I found that same kind of thing when looking at the amp diet. We saw that, oh yeah, ducts have a definite impact on the number of amps you need to stay comfortable. But in another project where we went and did analysis of retrofit of homes in the Bay Area, we we learned the tough lesson of you kind of got to meet the customer where they are. And so some people are ready to move to zonal living and ductless, and other people want to do more what in the guide we call box swapping. They want to keep their system type, but change the source of heat from gas fired to heat pump provided. So it basically, for me, it looked like it didn't make sense to argue with the customer about what type of zonal living or distribution they have, but just to try to help them electrify with the way they're leaning.
Yeah, and I think that's a good point. I mean, for most people, trying a heat pump is the first level of innovation they're willing to try, and they, if at all, right, they may not at all be comfortable with that.
Mm-hmm.
There's a technology that is really common, which is to if someone has a central air conditioner on their home with a gas furnace,
right?
I mean, for a small amount of money more, they can actually put a heat pump on and at least start to live with a heat pump and maybe have that do a portion of the heating in their home.
Right.
You know the difference, right? It's yeah.
And those look like great opportunities when either their central air conditioner is getting old or their furnace is getting old. When either one is getting old, switching over to heat pump is an easy thing to do. One of the ways I look at it in my 2,200 square foot house, and I've just put in a 1-ton Mr. Cool mini split, was, I'm just going to dabble in this, and it's cheap enough on a DIY basis to put in 1-ton mini split, and I'm loving it. And then I'll decide later, do I want a second one somewhere?
Yeah.
Do I want to get more control over the house or just let the heat drift throughout?
And so you're loving your Mr. Cool that you tried?
Yeah. Yeah. And it's, so I look at it as, hey, cheap experiment, under $2,000 and a few hours, but I'm an engineer and I like tinkering. So it's a way to dabble in it and see what happens.
That's how we've sold, I would say, the great majority of the ductless homes that we've sold. There was some kind of working system in the home and it was still working. And so we put the ductless in like the main living area of the home and let people try it. And the level of consumer satisfaction is so off the charts, which was encouraging, right? To have like 91% of the people that were surveyed by the utility program that we largely work with were very or extremely satisfied. They loved it. And then on top of it, it just was a trial. It wasn't this big expense. It was a modest expense to try some cool new technology. So I think that's a great strategy for markets like, like California, where they're really just getting started with whereas the Northwest where I live, ductless is now an everyday product that's sold.
Oh, we do have a question here from Eric. You guys can hear me, right?
Yes.
Yeah.
Okay. If you currently have a ducted system, isn't it expensive to convert to a ductless system? I'm curious to hear your guys' thoughts on that.
Yeah, it can. I mean, it can be, but I think you can. So I made my own house was a case study in how expensive and how unnecessary it can be if you try to convert every room in the house. And so what I did is I removed all of the ductwork and I put a ductless indoor unit in every space.
Oh boy.
And I had 9 zones, let's say. And it turned out that I needed probably, first of all, 6 to do my house. And so that was a big difference. And then I bought a very big, complicated heat pump system. It was very expensive to install because of, trying to make all the pipes and tubes weave through my house to get to that one heat pump outside. And there was a whole host of cost and other issues that arose because of the overcomplication that I designed. And so that was in my presentation, the keep it simple. I now have largely removed that system. And I now have little mini splits like your Mr. Cool type style, a small outdoor unit with a single attached indoor unit. And I just have like 4 of those around my house. And it is so much more comfortable. It's actually more comfortable.
Oh, yeah.
And it's less expensive to operate by an enormous measure. Like I use about half the electricity that I used to use with my bad first experiment. And so to the question, it is a cost to convert, but it doesn't have to be a outrageously expensive process. And that's why I go around talking to contractors and I tell these stories to hope that they don't make the mistake I did when I first got started. We tend to think that you have to have something that blows air in every single area, like a duct would, and you just don't need that with this technology.
Yeah, and I think also in my house, it matters too, or what really helps is it's kind of an open floor plan. So I can be injecting this 1 ton, 12,000 BTUs per hour in here in the bottom part of the house, and it's drifting its way upstairs and, through other parts. So, I don't need ducts. I've got, the house is a big duct itself.
Yeah, they move air far and wide, and they use different principles to move air, and that's how they're able to actually create greater comfort. Instead of getting into the technology, I'll just leave it at that. They really work different, and it's surprising how much more comfortable they are too.
Right. One of the things you mentioned in an early presentation a few months ago that really stuck with me was the term that what you saw in heat pumps was the ability to move a whole lot of thermal energy through a very small space, through the small tube set versus ductwork. And I recently watched somebody doing a central ducted system on I think it was This Old House or some show like that. And they had to spend so much labor time on the ductwork that they put in, building hard, sheet metal ductwork. And I realized, oh yeah, just being able to pull a line set, a copper tube line set through the attic and down to the unit, that would be so much easier than all this ductwork and gathering air and moving air around.
Yeah, it is really true. Like we discount that it took a lot more energy to build a house with ductwork, and then of course a lot more energy to move duct air, warm air, or cold air through ducted. My business partner, the guy who founded the heat pump store, built 3 houses over the last couple of years in his town, and he made them net zero homes, and he put just a little bit better than code plus in terms of insulation values, so they weren't a very expensive home to build. But he saved a lot of money in strategically using like a single zone ducted system and the heat pump water heater, right? And putting some good amount of photovoltaics on the house. And the floor plan was very conducive to operating that way. And it just goes to show, like, you can do less with more with this technology, because in fact it was designed to operate that way.
All right, I think we should wrap it up. We're about 12 minutes over our scheduled time, just to be mindful of everyone's time. Thanks so much for presenting. And I think Sean had to jump off to another meeting. But thanks to Sean as well for presenting. And just to let everyone know, this was recorded and we're going to post it on our YouTube site. We will be able to send it off to everyone who attended or signed up for the webinar. And yeah, so thanks everyone.
All right. Well, thanks everyone for hanging in there with us, and good luck on the electrification adventures.
Yes. All right. Bye.